All right, so let's take a look at this equation. It says which of the following statements is true? And it gives us a polynomial equation, x to the fourth plus 10x squared plus 16 is equal to 0. Well, I know from previous experience, from discussions in class, that there is a very important theorem called the fundamental theorem of algebra. I've never called it that in class, but that's what you have. When you have a biggest exponent here on this polynomial, that's how many solutions that you can expect to find for this equation. Okay, there won't be any more than that. Now, it's a little bit misleading because there might be numbers that repeat in our solutions. So we're expecting four numbers, but some of them may be complex numbers. We call them imaginary numbers, and some might be real numbers. And of those real numbers, some of them might repeat. But just knowing this is a 4 and expecting 4 solutions, I can come down here to C and say, no way is C the correct answer because it's saying that you have 3 solutions. Roots is just another name for solution. So this equation has 4 roots, not 3 roots. So because of this statement, I know that this can't be true. The other ones, the roots are 4, so it doesn't eliminate any more than that choice. All right, so the next thing I want to do is try to factor this because look, in all of these other choices, it says that we can factor this expression. Well, it turns out that we can use the x method even though this is not a quadratic expression. And that's because the exponent on this middle term, 2, is half of 4. So whatever exponent this is, if this exponent is half of it, we can apply the x method. So maybe they could have given me an exponent of 10, and half of 10 was 5. If this had an exponent of 5, I'd be able to do this x method. But they didn't give me 10 and 5, so I don't want to confuse anybody. All right, so to do this x method, we write down the middle term here, 10x squared, at the bottom of our x. And at the top of the x, we take the first term times the last term. X to the fourth times 16 is just 16x to the fourth. So now we're looking for two expressions that when multiplied together give me the top number there, 16x to the fourth, but when you add them together, you get the bottom of the x, which is 10x squared. Okay, so two numbers that multiply together to give me 16. Well, let's start out with 1 times 16. But 1 plus 16 is not 10, so that's not going to work. Hey, let's try 4 times 4. Oops. 4 times 4 is 16. But 4 plus 4 is not 10. Well, let's try 2 times 8. 2 times 8 is 16, and 2 plus 8 is 10. So we have found it. And this is what they call trial and error. The bigger this number 16 is, sometimes the longer this list and the more difficult it becomes to find the pair that you're looking for. So we've got 2x squared times 8x squared is 16x to the fourth, and 2x squareds plus 8x squareds are 10x squareds. All right, so I'm going to erase this trial and error because you can always pause that and write that down if you need on the video. I need this space to continue my work here. Now, before I erase all of it, I should make sure I write down my results, my answers. Here, let's even do it in red so it stands out to me. 2x squared and 8x squared. All right, so let's give ourselves a little bit of room. So after we have found the information in our x, they normally will tell us to create a table. So let's do that. In our table, along one diagonal, we just take the first term and the last term from the original equation, x to the fourth and 16. Along the other diagonal, we take the information that we found in our x, and it doesn't matter whether I write the 8x squared in this box or if I write the 8x squared in this box. Just make sure that we write that information along the diagonal. So on the bottom here, if we go across, we can see that these share a common factor of 8. And when I go across here, the 1 and 2 don't share a common factor, but as far as the variables go, an x squared is common to both. Now, when I look at this up and down here, 8 and 1 don't have a common factor, but with the variables, an x squared is common. And these are both even numbers, so 2 and 16 have a common factor of 2. Well, that means that this original equation, that we can factor it to x squared plus 8, what I found here on the left, times x squared plus 2. That looks different, but that's the same thing as the expression on the left-hand side that they originally gave us. Now, this is an equation, so I don't want to forget the equals 0. So if these represent numbers, if these two numbers multiply together to give us 0, then it has to be true that x squared plus 8 is equal to 0, or that x squared plus 2 is equal to 0. Or maybe, both would. Let's subtract 8 from both sides, and we get that x squared is equal to negative 8. Let's subtract 2 from both sides, and we get that x squared is equal to negative 2. But we have a problem here. This squared means you take a number and multiply it by itself. Well, if that number were 0, 0 times 0 is not negative 8. If it were a number like positive 2 times positive 2 is positive 4. Positive times a positive is never going to equal a negative number. What if it were a negative number, like negative 2? Negative 2 times a negative 2 is a positive 4. Negative times a negative is positive. So this has no real solution. And with this exponent of 2, what we say is that it has two imaginary solutions. And we'll learn how to write those solutions later. And over here, these two are two imaginary solutions. So it doesn't have any real numbers that are solutions to this equation. Well, let's come up here and look at our choices and see what we have. We found that it factored to x squared plus 8 times x squared plus 2. It did not factor to x squared plus 7 times x squared plus 2. It was plus 8, not plus 7. Well, so now the final decision is going to be the top statement says that the roots, the solutions to this equation, were positive 2 and negative 4. This one down here says that there were no rational roots. Well, rational roots are fractions, and those are real numbers, and that's the one that we have here because we didn't have any solutions that were real numbers. All of our solutions were imaginary. We didn't have a solution of 2 and negative 4. No way that's the answer. So our answer here is choice D. All of these statements are true. There were no rational roots, and in fact, we even gave them a better answer and said that the roots are all imaginary numbers. Hope that helps, and I will talk to you later.